everyone. Welcome to today's lesson. We would like to look at an important concept in limit, which is one-sided limit. Now, this time around, we want to approach the limit from different sides, right, or particular side. So we have what we call the left-hand side limit, which is denoted by the limit as x approaches a from the left. So we use this minus sign on top to denote that we are approaching a from the left of f of x, right? And then we have the right hand side limit, which is also denoted by the limit as x approaches a from the right of f of x. So take note, one thing I need you to be careful here is when we are approaching the limit, when we are finding the limit and we are approaching the value from the left, we use a negative sign on top, right? And that is what you see here. That does not mean that a is negative, no. It is just a sign to tell you that we are approaching a from the left. And the positive sign we put on top of a also shows that we are approaching a from the right. Now, these two side limits helps us to determine whether if the limit exists. So it leads us to a conclusion where I would like to give you that conclusion. So if the limit as x approaches a from the left of f of x is equal to the limit of f of x as x approaches a from the right, then we say the limit of f exists, right? You need to know this you need to know this particular condition. So for you to prove that the limit exists, this must hold, right? You should be able to show that the left hand side limit is actually equal to the right hand side limit, right? If you're able to show this, then it means that the limit exists. All right, let's quickly look at some few examples. So example 1, I have a piecewise function f of x, which is equal to, so it is 5 minus x when x is less than 0. Then it is x squared plus 1 when x is greater than or equal to 0. So we want to determine, so the question is determine whether the limit as x approaches 0 f of x exists. So this is what the question says. We want to determine whether if the limits of f of x, here f of x is a piecewise function. We want to determine if the limit exists as x approaches 0. So you remember the condition, this particular condition. So all that we need to do is that you need to calculate the limit. You need to find the limit as x approaches 0 from the left, and then also find the limit as x approaches 0 from the right. If we get the same values for these limits and they are equal, then we can see that the limit of f of x exists as x approaches 0. So we are going to use this to learn how to find the one-sided limit and then conclude based on that if the limit exists. All right, so I'll go ahead and find the limit as x approaches 0 from the left. Now here you see f of x is a piecewise function, right? And it is 5 minus x when x is less than 0. It is x squared plus 1 when x is greater than or equal to 0. So if we are approaching 0 from the left, right, of which this symbol shows that we are approaching 0 from the left, and that's the limit we are finding. So if we are approaching from the left, it means we are considering all the values less than 0. So this helps us to know that we are choosing this particular function. Because if you are approaching 0 from the left, then we are looking at all the x values that are less than 0, right? And which function fits that prescription? It is the 5 minus x. So we are going to pick the 5 minus x. Use that for our limit as x approaches 0 from the left. And so quickly, you know how to find this limit. That is 5 minus 0 and this is equal to 5. So the limit of f of x as x approaches 0 from the left is 5. Then I'll go ahead and find the limit as x approaches 0 from the right. This time around, we are interested in the x values that are greater than 0, right? So we come back to the piecewise function, and then we realize that that particular prescription, this particular function, or this particular expression fits it for x greater than or equal to 0. We are picking x squared plus 1. So we use that to evaluate the limit, and that will be 0 squared plus 1. This is equal to 1. Now, what can you observe? Now, when we found the limit as x approaches 0 from the left, we got 5. And then when we found the limit as x approaches 0 from the right, we got 1. So clearly we can see that the limit as x approaches 0 from the left of f of x is not equal to the limit as x approaches 0 from the right of f of x. Hence, we conclude that the limit of f does not exist. So DNE means it does not. So since the left-hand side limit is not equal to the right-hand side limit, we conclude that the limit of the function f of x does not exist. All right, so we go ahead to do second example, and I would like you to pause the video to do that second example. Let me quickly write second example here. So example 2. So we want to determine whether the limit as x approaches 1 of f of x exists, where f of x is equal to this piecewise function. We have x squared minus 1 over x minus 1. Whenever x is less than 1, then we have 2 whenever x is greater than or equal to. So we are to show or determine whether if the limit as x approaches 1 of this function f of x exists. Now here f of x is a piecewise function. All right. So you already know the condition for the limit to exist. The left-hand side of the limit and the right-hand side of the limit must be the same. They should be equal. I'll go ahead and compute the limit as x approaches 1 from the left. The question is, which of these two functions am I going to use? So if we are approaching 1 from the left, then it means we are looking at the x values that are less than 1. And clearly, it fits, this function fits that prescription. So x less than 1, we pick this particular function. Then we use it to evaluate our limit. So we have x squared minus 1 over x minus 1. Now here you need to be careful, because when you substitute 1 into this, you are going to get 1 minus 1 over 1 minus 1, which is 0 over 0. And this thing is what we call indeterminate form. And we don't want indeterminate forms as answers whenever we are evaluating limit. That means something must be done to the function, right? So let's see. What can we do? The numerator is difference of two squares. We can write it as x squared minus 1 squared over x minus 1. And that is difference of two squares. So x minus 1 over x minus 1 times x plus 1, all on x minus 1. And clearly, we remove x minus 1. They cancel. And that's what was giving us the 0 over 0. So now we find the limit as x approaches 1 from the left of x plus 1. That is equal to 1 plus 1, which is 2. All right. So the limit as x approaches 1 from the left, which is the left-hand side limit, is 2. Now the next thing is for me to find the limit as x approaches 1 from the right. Let's go back to the piecewise function. Now if we are approaching 1 from the right, then we are interested in the x values that are greater than 1, right? So we are in this particular region, and we are picking 2 as the function. So we are going to find the limit as x approaches 1 from the right of 2. Now there is a property in limit that whenever you take the limit of a constant is just the constant itself. Here, this limit is just 2. Now, what can you observe? So we can see that, let me scroll down a little bit. I can write. Now, we can see that when we approached the limit, when we approached 1 from the left, we got 2. And when we approached 1 from the right, we got 2. So clearly we can see that the limit as x approaches 1 from the left of f of x is equal to the limit as x approaches 1 from the right of f of x. Hence, you can confidently conclude that the limit of f exists. Right. What is the takeaway here? The takeaway here is that we use the one-sided limit to determine the existence of limit. That is, if you are able to show that the left-hand side limit is equal to the right-hand side limit, then we can confidently conclude that the limit of the function exists. If they are not the same, then the limit does not exist. All right. Thank you very much for watching this lesson, and I hope you enjoyed it.